Welcome to this class. In this session, we introduce the concept of Laplace transform for functions. So we are going to define what we mean by a Laplace transform of a function, and then do a few examples on how to determine a Laplace transform of functions. So let's begin the screen. So Laplace transform of a function is defined as so this is how we define a Laplace transform of function f of t. So the function should be defined on the interval 0 to infinity. Then the Laplace transform of this function f of t is another function capital F of s defined by this integral 0 from 0 to infinity e raised to minus st times the function f of t dt. The domain of f of s is the set of all values so if we call this star, for which star the integral given is star, exists. So the Laplace transform of a function f of t can also be denoted by L of f of t. So this is another way of writing the Laplace transform. So note that this is an improper integral. This definition of the Laplace transform, we have an improper integral. And so we must always ensure that the integral converges. So note the integral in star is an improper integral. So more precisely, this integral 0 to infinity e raised to power minus st times f of t dt is the same as limit as r approaches infinity, integral from 0 to n, integral from 0 to r, e raised to power minus st times f of t dt. So whenever the limit exists. So let's demonstrate how to find Laplace transform of some basic functions. So examples. Example 1, find the Laplace transform of the function f of t given by 1 whenever t is non-negative number. Now, solution. We know that Laplace transform of a function f of t is defined by the integral from 0 to infinity e raised to power minus st times f of t dt. So this is by definition. So this implies that Laplace transform of 1, which is our f of t, as defined by this, is integral from 0 to infinity e raised to power minus st times 1 dt. Now, this is just the same as integral from 0 to infinity e raised to power negative st dt. So which can be written as limit as r approaches infinity, integral from 0 to r of e raised to power minus st dt. Now, when you integrate this function using substitution method, you will get limit as r approaches infinity of 1 over s minus 1 over s e raised to power minus st, and then t from 0 to t equals to r. So this can be written as negative 1 over s limit as r approaches infinity. Now upper limits are then of e raised to negative st t from 0 to t equals to r. So this means we'll have negative 1 over s and then limit as r approaches infinity. When you replace the upper limit, you have e raised to minus sr minus t for 0, we get e raised to power 0, which is 1. Now, as r approaches infinity, this will be 0. We have negative s into 0 minus 1. And this will give us 1 over s for all values of s greater than 0. So therefore, Laplace transform of 1 is 1 over s. And then example 2. Example 2. Find the Laplace transform. Find the Laplace transform. Transform of f of t given by e raised power at, where a is any constant. So that's another problem. Now, for this one, solution, we also know from definition, so we know that Laplace transform of any function f of t is given by the integral from 0 to infinity e raised to minus st times f of t dt. So our f of t is e raised to power at will be given by integral from 0 to infinity e raised to power minus st times e raised to power at dt. So this will give us Laplace transform of e raised to power at is integral from 0 to infinity. Now, using loss of indices, this is like e raised to power minus st plus at, which can be written as e raised to power minus s plus a raised power multiplied by t, or it can be written as e raised to power negative s minus a times t. So I write this one as minus s minus a t dt. So I've used just lots of indices to rewrite this product of e raised to minus st, e raised to at. This will give us same as limit as r approaches infinity of integral from 0 to r e raised to negative s minus a times t and then dt. So this Laplace transform of e raised to power at. Now, using substitution method for integration, this will give us limit as r approaches infinity of minus 1 over s minus a times e raised to power minus s minus a t and then t from 0 to t equals to r. Now, since minus 1 over s minus a is a constant, doesn't depend on r, so we can pull it out of the limit. So negative 1 over s minus a, then limit as r approaches infinity. Now, e raised to negative s minus at can be written as 1 over e raised power s minus a times t, and this is from t to 0 to t equals to r, which is the same as negative 1 over s minus a, limit as r approaches infinity of upper limit will give us 1 over e raised power s minus a times r, also replace t by r, minus t for 0, e raised power 0 is 1, 1 over 1 is 1. Then as r approaches infinity, this part will approach 0. So this will be minus 1 over s minus a times 0 minus 1. Remember, limit of a constant is a constant. So this will just be 1 over s minus a, and this applies for any value of s greater than a, because this thing must be non-zero and positive. So therefore, Laplace transform of e raised power at is given by 1 over s minus a, where it works for all values of s strictly greater than a. So in the next session, we'll give more examples on how to calculate Laplace transform of some basic functions. Thank you.